Awesome, it worked. Oh, hey, didn't see you there. One of my favorite things about programming is scratching your own itch, and I think that's one of the best ways to learn how to program. And today I want to talk about how I scratched my own itch with Zig and solved a problem with my Discord server. So I run this Discord server called Code with Cypert. It's right here. It's a small community, but I think we're growing, and it's a nice group of people who actually have meaningful discussions and help each other out. And it's good. It's a great place to be. But one of the things I want to do is I've got these news channels over here. So I've got like Zig News, Go News, and then I've got a blog feed and a video feed. And I want to post my updates to those. And I was using Zapier for a while. And like they say, Zapier makes you happier until it doesn't work. And I was running into issues with it not posting things to Discord, and the zaps were failing. And I said, okay, well, how do I solve this for myself? And I started to put together something in Go a while back and said, no, let's do it in Zig. This is a great learning opportunity. So I want to talk about that learning opportunity. So what I ended up building is this project called Updog. And you might be wondering, what's Updog? And my response would be, Updog is a Zig-based feed parsing library, and it supports parsing RSS feeds, Atom feeds, and even JSON feeds. The features, full disclaimer, I did have AI write this README for me just so I had a README. So, more or less this is correct, but there might be a few things that are off, and I'll change it and adjust it as we go. But the idea here is essentially that you get a couple different parsers. So you get an RSS parser, an Atom parser, and a JSON feed parser. And then more specifically, you get a unified parser that attempts to figure out what format feed it is, and then delegates to the appropriate parser, and then maps everything back to these standardized constructs. So this is really cool. This is a library that I've wrote, and we'll talk about the source code here in a minute. But this doesn't solve the problem, right? I need to actually post to Discord as well. Well, that's where Smells Like comes in. And I couldn't come up with a better name for this, so I just wanted to play on the pun, Smells Like Updog. And yeah, so this is a Zig-based. Really, it's a GitHub action, and it runs in GitHub workflows every 6 hours, and it uses Updog and some text files that I have here to map to our channels. And those text files contain feeds, and it parses those feeds and generates a state file. And the reason I'm telling you all this right now instead of going into the code is so you have an idea of what we're going to talk about, because we will go into the code. And I just want to make sure that you are aware of what we're getting into before we actually dive into it. So with that being said, let's dive into it. Let me close out this specification, and we can close out one of these terminals and then make the other one much bigger for your viewing pleasure. Okay, yeah, that should be big enough. Okay, so Updog. So we talked about that README. We talked about the unified parser. There's really not a ton going on here. This is a zero dependency project, which was another fun little tidbit, was making sure that this dependency list stayed empty. Originally, I had thought about using Nectro's lib or XML parsing library. I also found a streaming XML library, and ultimately I just decided to write my own. It seemed like it would be a better solution for me, especially since I don't need a ton of bells and whistles with the XML parsing. Okay, so with that being said, let's get into some code. So our root.zig is essentially just re-exporting our 4 different parsers. So we have our feed parser, which is the universal parser. We have our RSS parser, our Atom parser, and our JSON feed parser. So we can take a look at these. There's technically one more parser that we haven't talked about, which is that XML parser. So if I were to go to the definition for this RSS feed and then go to the definition for this XML parser, you can see that we have our little XML parser here. This isn't perfect, but it is meeting my needs at the moment, and I will fix issues as they come up. So I'm pretty happy with how it's turned out. It's also like with tests, 500 lines of code, which feels pretty good. And there are several tests, so hopefully there's some confidence in here that this works. And the fact that I've got a working project with it helps boost that confidence too. Actually, there's quite a bit of tests. Okay, so with that in mind, that's the XML parser. Let's close out of that, and we can talk about maybe like the RSS parser. So you can see here We use error unions. We have our RSS error, different error types that we support or could run into, I guess I should say. And then we have a struct modeling an RSS item. So this is essentially taking fields from the RSS spec and then mapping those to a Zig struct. RSS channel is more or less the same. It's a struct from the RSS spec, and we're mapping it to a Zig struct. And then RSS feed has information about the feed itself. So the RSS version, it has the channel, again, from the RSS specification. The parser itself takes in an allocator, and we have a parse method here that uses the XML parser to parse the XML, and then it takes the values from the XML and converts those into RSS. That's generally the flow for, I say all of these except for the JSON feed one, because that's JSON and not XML. But the idea here was essentially if I could parse the XML and then I can map the XML to RSS or map the XML to Atom, I would be good to go. So here's some of the code here. I could walk through this line by line. I don't know how valuable that would be. The source code is all on GitHub, as we saw earlier. So if you would like to peruse it and learn from it, that is available for your viewing pleasure. Okay, what else? Anything interesting? Just parsing the channel. I mean, it's really just checking the content of the nodes and then trying to assign it to the right thing. So for example, if it's a link, we assign it to the link. If it's a title, we assign it to the title. If it's a description, we assign it to the description, and so on and so forth. Finally, we return that RSS channel here with all of the fields, and we have a parse item down here that is parsing the items itself. So again, up here, parse channel. Down below, we have our parse item. There's a little bit of duplicative text here that we might be able to reduce as well, but for now, this is fine. And then we get into some tests. So this is kind of the gist of it. Outside of this, there's the JSON feed parser, which is a little different. It's using, actually, it follows quite a few similar patterns. So we have our errors at the top. We have a bunch of structs modeling the JSON feed specification. And then we get into the parser, and we're just using standard JSON, and we're parsing it from a slice, and that's giving us our JSON. And then we call parse JSON feed on that object, and we run through it and parse it and build out an array list of the things that we need. So authors, build out an array list of items, everything like that, and then we return a JSON feed struct item down here at the bottom. Really not a ton going on in the actual parsing itself. It delegates the RSS and the Atom feeds delegate a lot of the heavy lifting to the XML parser, which is great. That works out great. But yeah, that's the gist of this. Actually, I think I have some examples. So if you were curious about what this looks like, here's an example of the universal parser. So we've got a debug allocator up here at the top. We have an RSS feed that we're just inlining as a string. We have an Atom feed that we're inlining as a string. And then we have our JSON example right here. Down here, you can see we're handling the RSS feed like so, calling parser init, parser parse, and then we're deferring the deinitialization of it, and then we're just printing it using this print feed helper. Same with Atom, and same with JSON. And you can see down here that we're actually printing those like you would expect. In the print feed, it just goes through all the items, the fields in the struct, I should say, and if they exist, it prints them. Otherwise, it tells you that it's missing, or in some cases, it just doesn't tell you that it's missing. There's also examples XML. So if you wanted to see specifically what the XML parser looks like, it's right here. There's an XML struct. We call parser init with an allocator and the XML string, parser.parse. And then, of course, we defer deinitializing that. And then we're just iterating through the items here. The XML parser is more raw and I don't want to say unstructured because it's equally as structured, but it's not as abstract as the structs that are provided from the, or not as abstract, I guess I shouldn't say. That's not true. It's not as higher level as the structs elevated from the RSS specification or the Atom specification or the JSON feed specification. Okay, so that's Updog. How do we actually get this stuff into Discord, right? So let me go back and let's hop into Smells Like. And these names are so fun. So Smells Like is the Discord poster. So I can cat the README. You can read through the README here if you'd like. Again, just disclaimer, this README was AI generated. It's a bad habit, but it is really nice having an AI run through and generate these. It saves me a lot of time. So It's a Zig-based RSS Atom JSON feed aggregator that posts to Discord channels via webhooks. So there's information on the features, blah, 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 all of that. The channels, how this stuff maps to the text files map to channels, although it's actually done in source code. And then requirements, and then specifically the part that's interesting, you need these webhooks. So how do you get these webhooks? So if you were to go to your Discord server, and then you go to your channel, and you go to integrations, and then you go to webhooks, you can create a webhook here, and then you can click on a webhook, and then if you copy this webhook URL, that will give you the webhook URL that you will set as the environment variables. So these environment variables. There's also a dry run mode because I was testing the crap out of this, and I didn't want to ping the Discord server more than I had to. So the dry run mode doesn't actually post. Some information on how it works, including things like state saving, which is kind of neat. Duplicate detection, which maybe isn't the best way to phrase this because it checks whether it was posted via the state file. It doesn't check whether it exists in Discord. That might be something worth changing at some point, but for now, this is fine. Those text files and how they work, all of that stuff. Let's get into some code. That's what you're here for. So like I mentioned, we do use Updog. So Updog is a dependency here. So we have to specify that in our build.zig.zon file. And then we have to wire it up in our build.zig. You've probably already seen how to do that before, but just in case you haven't, we add imports like this, and it's a module. Specifically, we're pulling in the feed parser module. You can see the dependency here, Updog, and it's your standard build.zig stuff. I feel like I've done enough videos on that we don't need to dive into that in this one. Okay, now the source itself, everything is in main.zig, except for the channels. So let's just talk through what the channels look like. So the Zig News channel is like this. So it's a text file. There's a new line for every feed that we want to parse. Interestingly enough, I was running into some issues with the openmymind.net Atom feed. I thought it was Atom-specific issues, but I can pull in tiger beetles with no issues whatsoever. I think it's an IPv6 issue, so I don't know. I got to sort that out. But in the meantime, everything else works. So I have these feeds, right? So it iterates through these feeds. I built in support for commenting them out like this, so I don't forget that I want this feed in my aggregation, but it doesn't work at this point. So I don't break the application trying to parse it. And then, some other feeds. So Tiger Beetle, Loris's feeds, and then AK's personal feed as well. So that's really the channel setup. So the last thing we have to talk about would be the main.zig. And I will warn you, this is a little sloppy compared to the Updog library. I'm refactoring this as we go, but I felt like it would be a good time to make a video. So we're making a video. Okay, so there's a state file. It's called state.json, which we haven't talked about. So let's just really quickly go into that. This is what the JSON state looks like for the most recent run. So you can see that it posted my blog post using C libraries and Zig. It posted a YouTube video. It posted a Tiger Beetle post, and then it posted another YouTube video. So with that in mind, that's really the contents of our state file. It's JSON. We write JSON. We read JSON. So we'll get to that at some point. Standard allocator stuff. We have this check dry run, which is essentially just looking at the environment variables that are available. So if you set the dry run environment variable to true and then run this, it will be a dry run. So if it is a dry run, it warns you. It tells you that, hey, no posts will be made. We try to initialize our environment. This is something I could probably clean up a little bit. I pass in whether it is a dry run or not, and then we duplicate these like fake items so I can deinitialize them later. It's kind of sloppy. Something worth improving going forward. And instead, what I would do is just check if it's a dry run, and if so, then I would actually use this environment. And if not, then I probably would just create like an empty environment struct or something. We have our state struct, so we have our state loading. We pass in an allocator for that. This is fairly straightforward. We create a hash map, and then we get the timestamp from the last run. We open that file. We're reading that file to the end here. We're parsing it here. And then, as we're handling errors along the way, we're returning these states that are indicative of the fact that something went wrong. do some math on our timestamps, figure out our cutoff. So we have, worth mentioning, we do have a cutoff of retention days. So we kind of clean up the state file as it goes to make sure that it doesn't get too big and become a pain to manage. Yeah, I think that's mostly it for the state file. Some debugging indicating that we are doing things. And then really the meat and potatoes of this is this process all channels. So if we go to this, you can see that we open the directory source channels, we get our iterator, we check the iterator here. If it's not a file, then we just continue. And if it does not end with a .txt, we also just continue. But if those things are true, we decide to process that channel. So we pass in a lot of arguments to process channel, including the allocator, the env, the state, the directory, the entry name, and whether it's a dry run or not. And then if we look at process channel, you can see here that we have a method to get our webhook for a channel, which if we look at this, it's really straightforward. We just map the channel name to the environment that we had built previously. We open a file that has all the feeds in it. So the text file, we read the file to end. We split on new lines, and then we iterate through those new lines and we trim those up. And then finally extract a URL from those new lines. And worth mentioning, this is where we handle out the commented blocks in the text file. And then finally, we call process feed. Process feed does the actual fetching. So it fetches the URL contents to first fruing it, passes the string representation from the XML or JSON feed, whatever we're getting, into the Updog parser. And then as we walked through with Updog, Updog takes care of the heavy lifting here. So we call parser.parse. We deinitialize our feed. Sorry, we defer deinitializing our feed. And then we iterate through these items. So for each item, we check if there's a title. And then we essentially, what we're doing is we are checking if it's posted already. And if it's not already posted, then we're checking if it should post it based on the date that it's published. And then if it is if it should be posted, then we're actually posting it to Discord unless it's a dry run. And then we're modifying the state to mark that that item has been posted. Quite a bit going on there. But really, that's most of the application. So if I were to go back here, so that's process feed, we go back to process channel. I think really the last thing we have left is just updating the state file. So you can see that we set the last run timestamp to the current timestamp, and we call state.save. And then if it's a dry run, we indicate, hey, the dry run completed. These number of items would be posted. Else, new items have been posted. So if it's not a dry run, these are the ones that were actually posted. That's it. That's really the project. I'm sure walking through that source code, you could see that there's quite a few things that I could change, and maybe I could structure this as a better pipeline of operations, and maybe that's something I will do. But I really wanted to solve this problem for me because the Zapier webhooks integration with Discord was not working. Worth mentioning, I feel like I should probably show you that this works. So if I remember how to specify that it's a dry run, and then I'm going to go ahead and remove the state file so we don't have anything to check. So it should post something. It's in a dry run, so it won't actually post, but it should think that it would post something. So if we zig build run, you can see that it's processing all of these items. And it says 3 items would be posted. And then the state file has been updated. Run without dry run to post for real. So the last thing we really haven't talked about is how the heck does this run in GitHub? So if I go to GitHub workflows and then feed processor.yaml, I've got this process feeds workflow. I need to set the permissions for contents right so that the GitHub action itself can update the state file because the state file is in the repo. This runs every 6 hours, but I also allow manual trigger with workflow dispatch. And then the jobs are down here. So really it's just one job. It's the process feeds job. It runs on Ubuntu latest. We check out the repository. We set up Zig, specifically 0.15.2. Interestingly enough, the post requests in 0.15.1 were hanging with the Discord server webhook. So whenever I would post to the Discord webhook URL with the standard HTTP client, I was getting error connection reset. What I found was that this was a known bug in 0.15.1, and the solution was to upgrade to 0.15.2. So this also is my first 0.15.2 project. So yeah, fun little tidbit there. We run Zig build. I'm building from source every single time. Probably don't have to do this. Probably could just build a release and then make the release available to run. I use some secrets, specify those secrets as environment variables, and then I run that binary, so the smells like binary. Finally, we commit the state file, and then we push those changes back to master, or rather to main, sorry. And again, what that gives us is this. So we have our actions that we can check here, get a little indicator whether they passed or failed. And then you can see the state file, the most recent state file here. So you can see the last run timestamp, the things that have been posted. And yeah, that's the project. So hopefully you found this helpful. This was a fun little project for me. And yeah, scratch your own itch with a programming language. That's a great way to learn it and a really fun way to solve a problem and stay motivated as you're working through the hard parts. I think that's it. If you haven't yet, you should join the Discord. It's getting nicer and nicer by the day, and I'd love for you to be there. Help make it a nicer place. Outside of that, don't forget to subscribe to the channel, and if you found this video helpful, let me know in the comments below. Thank you, and have a great day.